Hey everybody, this is Mitch Ashley,
and Alan Schimmel,
and you're listening to
Security Boulevard Chats.
Yeah, baby.
All right, Mitch. So now it seems like a well-oiled machine.
We're getting this down,
Yeah, man.
Dogs can learn new tricks.
Yeah. Well, I think it's old dogs just relearning old tricks.
Oh, that's true. Remembering tricks.
But it's like the land of 51st dates. It's like every day's a new day.
Every day's a new day. Groundhog Day.
Yep. We learned it again. Anyway, so Mitch, as usual, a busy week in security. We've got our requisite reaches happening in the tech world, our requisite security companies either doing layoffs. A lot of good friends at Cisco, a lot of talented folks at Cisco got laid off in the last week. Some of the public companies have lowered their guidance in terms of revenue. That's a tough time, but there's also excitement building with RSA this year, just a few months out. For those who don't know, at our annual DevSecOps event at RSA, seminar, I think is the official word. It's an all-day event within RSA at Moscone Center, and it's on the Monday of RSA week, which this year's Monday, May 6th. We're going to be focusing in on, DevSecOps in the world of generative AI.
Mm-hmm.
And we've got some amazing speakers, right? David Brin, acclaimed, multiple Hugo Nebula award-winning sci-fi author, PhD, NASA JPL fellow there. Also one of the, preeminent futurists for the last 30, 35 years in the world. Mm-hmm. Then we have, CISOs and senior security people from OpenAI, DeepMind, Google, Meta, Anthropic, more. And of course you have a panel going on. But I think, what we may lose sight of in the bright lights of all that is the very real question of inherently, what's the relationship between security and AI here?
Mm-hmm. I think
right? Is it a help? Yeah. Is it a help? Is it a foe? Is it both? Is it everything to everyone all at once? I don't know. What do you think, Mitch?
It seems like there's sort of two or three different threads. One is attackers and what they're going to do with AI. How does that aid them? And then the response is what in AI can help us both thwart that or prevent that, as well as other general security attacks. I think the second thread is automation, right? What can we do to help improve the SOC? What can we do to help improve incident response? Whether it's information that can be surfaced through generative AI or machine learning and other things in AI that might help us with, we've got all this data, all this traffic, all these attacks, what can we learn from all of that? And then I think the third one is sort of that biggest unknown is like, well, what aren't we thinking of that AI might be able to help us with that we're sort of, current paradigms don't set us up to think initially about that are really innovative and kind of move the ball forward. Because you've heard me say before, security is kind of a funny thing that we're still doing the stuff you and I did 23, 4, 5 years ago. Those things are still there. And that the pace of innovation has happened, but I don't know. My sense is always like, we could be doing a lot more. How do we help that get done faster?
Yeah.
Maybe AI is part of helping that accelerate.
I think it will be, and it should be. I'm a binary kind of person. I don't know if that really.
Are you a binary star?
Yeah, or non-binary. I forget I always get confused. But anyway, the way I look at it, Mitch, is I look at AI through two lenses. One is, how can I use AI to help me make better security, for lack of a better phrase, to make the security better, right? AI is a tool I could use, and there are some obvious applications of it that will allow me to do more faster, better, cheaper, more efficiently.
Mm-hmm. Mm-hmm.
The evil twin of that is what do I need to do to secure against AI? So AI in the wrong hands or AI pointed in
Defense.
the wrong direction, right? And what, that's part of my job now. If I'm a security person, that's part of my job. How do I defend against AI generated attacks or AI aided attacks, enhanced attacks? And that's really scary because you know what? These bad guys have just as good, if not better, an imagination than the good guys do. And many times they have just as big a infrastructure and,
They're also more directly
resources.
financially motivated, right? Than
Yep.
maybe a day-to-day security engineer who's doing this for, their passion or their belief in security.
Yeah, I agree. I mean, they're incentivized. The more they do, the more they make. So when I look at AI, it's unfortunately, I think the answer is AI is going to do a little or a lot of both of those things.
Mm-hmm.
But I'd like it to do more to help than to hurt.
Mm-hmm.
I think eventually it certainly will, but there's gonna be some AI and aided attacks. Excuse me. I think we already see it with phishing,
Oh, absolutely.
right? The level of phishing has gotten much better. I look forward to see what software and services I paid for every day when I get these emails for the receipt, for Norton or or any other of these kind of things, the Best Buy Geek Squads, and I get at least one or two of those a day. And where they used to be they were so bad they were funny. Now it takes me time. I go and I look at who the email is from. I look in the header to see the email, just to make sure it's really not from who it purports to be.
Mm-hmm.
Usually PayPal or something. So I look, and I think unfortunately, we're a lot closer to the beginning of this dilemma, or maybe not dilemma, to the beginning of this era than we are to the end of it.
Yeah,
So
I keep thinking there's low-hanging fruit things that we can do. Like, one of those, I have the this bugs me list. It's not very long, but a few things that I see, like, so if on a web page it can validate your email address, that it's a valid email address as you're typing it before you submit the form and all that kind of stuff. Why can't your email client validate the links in the emails that you're seeing so that they're really going to the Best Buy site and they're not some wonky thing? That seems like pretty low-hanging fruit. Should be a great application of AI. Maybe you don't even need AI to do that, but there are those kind of things. I think to your point about being at the beginning of this, I think we're already seeing, but we're really heading into this big area of questioning everything, right? Is that a deep fake? Is that not just an email, but is that a deep fake video? Is that a call from Alan? Voice message is a text. All of this stuff, I think, is going to teach us to question everything. The problem is, will it also teach us not to trust anything? Are we going to end up in this era where we don't believe anything because we just have no way of validating it? And that I think is one of the kind of bigger dangers about security and AI. Thinking about security engineers, how do we know I'm reacting on the right information? Right?
I agree. Look, this is, I think, a society-wide problem. And I think a lot of people, they look at the stuff that passes itself off as news today. I think there's some element of people who just believe it because it reinforces their worldview.
Yep.
But I think there's a bigger group of people who don't believe anything because they think it's all nonsense. And that reinforces their worldview too, I guess. And then there's probably a small minority who say, I'm going to validate it before I believe it or not. And they dig in a little bit. But most people aren't doing that. And it's, I think, a big problem in the world.
I think it's tough to ask everybody to do that. Not everybody is inclined to take the time, more or less, kind of really dig into it and say, maybe I don't want to do that.
Agreed. Excuse me, Mitch. Agreed. I wanted to bring up another topic today, though. We're going to be doing a video interview today on Security Boulevard Chat. And this is, I think it's the first time, well, since we relaunched this year, the podcast where we have a guest on. And look, I'm not fooling anyone. It's not a live guest that we had joining Mitchell and I when we made this. It's actually an interview I did with Chris Eng from Veracode this past week for TechStrong TV. And Mitch, you know Chris. We know Chris Eng.
Long time.
20-something years, man. Yeah, Chris is the VP of Threat Research, but he's been at Veracode through all of its incarnations. I think he might have been an at-stake guy even before Veracode. But, at-stake, if you remember, was acquired by Symantec, and then they kind of spun out, or the Chris is left there with some other folks and started Veracode. It was a long time ago for sure. Chris Darby was the CEO there, and of course Chris has gone on to amazing things. Anyway, I had a chance to catch up with Chris. Every year Veracode does their State of Software Security, SOSS. And what they do is, it's not a survey, it's not interviewing, but they take all of the data that they see or pass through, anonymized, obviously, to protect the innocent. And they draw trends out of it, and they don't even do it. Here's an interesting thing I was reminded of in talking to Chris. They actually deploy a data scientist firm. I want to say Cytera or something like that. Chris mentions the name in the interview. This is a data science firm that specializes in cyber. And so they're the ones who are really kind of crunching the numbers and coming up with the trends that make their way onto the front pages of this report. This year's report, like the biggest thing that they saw was security debt. And, and I spoke about this with Chris. It's actually ironic that I was the one interviewing him with this because, so much of in the early DevOps days was about technical debt.
Technical debt. It's all we heard.
How much?
Yeah.
Yep. I mean, how much technical debt do most organizations who have been doing waterfall or have been kicking the can down the road accumulated to the point where it was suffocating them, but it was so suffocating that they really almost didn't have an out without really biting the bullet with some catastrophic potential. And I guess I just never thought about it until Chris and this report came out. But it's the same thing with regard to security. It is a monster of a thing.
Absolutely. And there's also maybe a connection. I'm curious to see in this interview when we watch it, of some of that security debt comes from software debt, application debt, right? You're not updating this software. It's not, not able to keep pace with change and updating open source, vulnerabilities that might be in your own software applications and stuff. That also contributes to that security debt, as well as the workload and the backlog of security work that creates that debt.
Yep. Agreed. Anyway, Veracode in the State of Software Security has taken security debt as the star of this year's report. And they've drawn out some really good data there that gives you some really good insight. So if it's okay, let's run this video of the interview with Chris, and we'll be right back. Hi, everyone. Welcome back here to TechStrong TV. I'm happy to have a good friend of mine back with us here to discuss the latest research from our friends at Veracode. He's Chris Eng. Chris is the Chief Research Officer at Veracode and has been for a long time. I know Chris probably longer than either of us want to admit. Chris, welcome back. How are you, my friend?
I'm doing great. Thanks for having me.
Good. It's good to have you here. So, Chris, I think most of our audience is very familiar with Veracode. They're one of the pioneers in the AppSec market. And, as I mentioned, you and I know each other back, I think, from the at-stake days through all the various iterations of Veracode and corporate overlords and all that good stuff. But in case, I don't know, maybe someone out here is new or they don't know Veracode, how would you describe Veracode to them?
Yeah, we're a software security company, and we're trying to, we help our customers with software security at every stage of the life cycle. So everything from like the educational aspect for the developer through detecting and fixing issues as you're coding, to doing static, dynamic, and software composition scanning as you're getting ready to deploy, penetration testing after that. So everything you can think of sort of in the SDLC, we've always talked about integrating security at every stage, right? And so we're all about doing that in an automated way at scale. And it's taken a long time to get there, but I think the industry is realizing that you can't just think about this later. You've got to integrate it at every possible stage.
I get it. Absolutely. And of course you're being very modest, but Veracode is not just a software security company. You guys have really helped set the trail, if you will, or cleared the trail or made the trail, especially around application security, AppSec and stuff like that. And this is going back, I guess. Has Veracode been around 20 years? Is that fair, Chris? Around that?
Not quite, but we're getting pretty close. It was 2006.
It's got to be. Yeah. Okay.
And
I was going to say 2005, something like that. It was
the whole motivation. For me coming over was like I was sitting there doing penetration tests for customers, one off, 2 weeks at a time, and that just doesn't scale. And so when you start thinking about what does scale, how do you take the increasing amount of software that's being written by every company out there and scale that into a real program with process and tooling around it where you can, test your software and make security testing, as ingrained as quality testing or all the other things that you have to do to produce software. The only way to do that was to bring automation to it. And the thing for us in 2006 was like, well, let's put it in the cloud. We didn't have that word yet, but so let's put it in the cloud and get out of this mentality where you've got to give people this the software to install and maintain and have computers for, and let's just let them upload stuff and we'll handle that part of it. And that was what's really allowed a lot of big programs to scale over the years. And then we get a lot of great data out of that, which is kind of how we ended up writing this report.
Right, the byproduct of which is the State of Software Security report every year, right?
Right.
Like you can kind of see a lot of that data.
Yeah. You see what's happening, right, across different industries, different languages. Are things getting better or worse? Where are the concentrations of bad news and good news? And first 2010, we thought like, well, let's put something out there for the industry. The report had a data set of 1,500 applications, we were like, wow, 1,500 applications, like that's huge. This year's report has 1 million.
So just a little bit different, a little bit different, more scale.
And you can learn so much by just like number crunching that data and, starting to ask some probing questions of like what's happening out there. Of course, we do that hand in hand with our friends over at Scientia, who have the data science, security data science background to be able to really to dig into some of the complicated things that we want to do. So it's been a really cool journey, getting to do this every year and having, like I said, an increasing amount of like really rich application security data every year.
No doubt about it. Chris, before we dive into some of the nuggets from this year, the report is available now. If people go to veracode.com, they could download
the
report.
Yeah. Veracode.com/SOSS, which stands for State of Software Security. You can get there from the front page also, but yeah, they can read it. We released it actually just a few days ago.
Fantastic.
Fresh off the presses.
All right. So, Chris, let's start with, what are the big insights from this year's report?
So this year, what we chose to focus on was security debt. And you're hearing a lot about security debt lately, I think, in conversations, just in terms of what's piling up, and how difficult is it to kind of get on top of that. security debt as a concept, I think I always like to compare it to credit card debt or any sort of financial debt, right? Where if you accrue it and you don't pay it down, it gets more expensive to fix later, right? In finance world, it's interest. In software world, it's just sort of the complexity of software and the crusty old code and things like that. And technically, I think any flaw or vulnerability that you know about in your software that you choose not to fix once you know about it, that becomes security debt, right? You've decided to defer it. For the purposes of this report, because we're doing calculations and whatnot, we're defining security debt as anything that you know about and haven't fixed for at least a year. So that's that's an ample amount of time, right? So it's kind of fair to say yeah, you've let it slide into debt at that time. And so what we find is security debt is all over the place. It's endemic. It affects every application, every industry, every language, size of application, size of company doesn't really matter. And you just kind of find it everywhere. And you find that 71% of organizations have security debt. About 45, close to half of organizations have what we call critical security debt, which is flaws and vulnerabilities that are of a high or critical severity that you've let slide past that time. So it's pretty bad. Companies are letting this pile up, and over time that really, really accumulates.
Sure. To me, security debt is like dark matter, right? It may make up 80% of the universe, but we can't see it, smell it, touch it. But we see its presence based upon its gravitational pull, right, on regular matter or whatever. So, in my mind, security debt has a similar kind of thing. Because it's there, we may choose to ignore it, and many organizations kind of bury their head in the sand around it. But nevertheless, the gravitational pull of it prevents us or slows us down from doing things that we know we need to do, right? And I think in the case of security debt, it's almost sort of a ticking time bomb too, though, because sooner or later those chickens come home to roost, as the saying goes, right? And someone's got to pay the price.
That's exactly right. Nobody, most people would rather go and write a cool new feature, right, than go and fix some security issues. And on a day-to-day basis, you don't feel the security debt there unless you've got a security team pounding at your door or something. But you really feel it when there ends up being a large industry impacting event, like a Heartbleed or a Log4j or something along those lines. And that's where the security debt really comes back to bite you, because if you've allowed yourself to kind of get that far out of whack, like with an open source library, for example, if I'm up to date, if I'm only a month out of date and some big vulnerability comes out, it's actually very quick for me to just go patch that with the fixed code. Nothing's going to break. It's a really easy fix. If I'm 5 years out of date, imagine I can't just jump to the latest version, right? I have to kind of go step by step, go from 5 years out of date to 4 years out of date, take the next major version, make sure that nothing broke as a result, because I'm making such big changes to the code. When you can make small changes at a more frequent basis, you lower the chance that you're going to break anything. And that applies to pretty much any security fix that you're going to make. I think the longer that you let it go. And also if it's current, if it's recent in your memory, if you just fix it when you find out about it, you're already working on that code, right? As a developer, you don't have to go unearth it from some branch from a year ago and figure out what was I doing at that time, and what does this code actually do, and kind of get back into that mindset. You're already working on it, but it's a muscle, right?
Yeah, and it's muscle memory. So started doing DevOps.com about 10 years ago, right? And look, the whole technical debt thing was a big issue that DevOps was helping to address, right? Is a lot of organizations just kind of kick the can down the road.
Yeah.
And like you said, eventually it becomes such a big hurdle to get up to speed, to get up to par, that you just can't do it in one fell swoop. Now it takes time and more effort. And it's not that any one little thing is fatal. It's the totality of it, right?
Yeah.
That really weighs in. As I said, it's like dark matter. It starts morphing and pulling at the fabric of your stuff. So what's the answer here, though?
Yeah, there are some things that can be done, and one of the areas that we spent a little time investigating once we kind of looked at the nature of the debt and the volume of the debt is what are application teams actually, what kind of effort are they actually putting against this? And so if you think about, for example, what's my average monthly fix rate? Like if I have 100 flaws in any given month, how many of those flaws am I actually fixing within that time frame? Like what is my capacity as a team? And so we've defined capacity in that way. What percentage of the known vulnerabilities you have are you actually getting after month over month? Obviously, you want to be fixing faster than you're creating them. Otherwise, you get into more debt. But what you find is that most teams are not dedicating a lot of capacity to this. About 2/3 of them are dedicating like 3% capacity. I think if there's a chart in the report that kind of shows what that looks like. But it's like we're talking single digit percentages a lot of the times. And so, okay, that's, not ideal from a security perspective, but you're balancing a lot of things, right? You're balancing new features, you're balancing non-functional requirements, other tech debt, right? You're keeping your stack up to date, all these other things that you have to do as a software developer. So let's just say that your capacity is what it is. Let's say you can't change that, even though that you can, but it's a business decision and it's a lot more complicated than that. So given the past capacity that you do have, are you as a team using that capacity in the best possible, most efficient way, right? Am I getting after the highest risk items, knocking those off at least? And it turns out that largely they are not. Teams are not. So you would expect that you'd work on the most critical issues first, and once you kind of got through all those, you'd work on the medium severities and the lows. But when you look at a plot of the sort of the lifetime of those types of issues, you find that they're all being addressed at roughly the same rate. You see, there's a chart that has these lines and they overlap because there does not seem to be a prioritization there. And so that's one thing that's actually really easy to get after is prioritize the security work a little bit better. Because if you have only got a certain amount of time to work with, you really should be spending on the things that present the most risk to the business, not what you just feel like working on. And we can't really tell why it is that developers are choosing to fix the lower severity items first sometimes. I think a lot of it just has to do with convenience. I'll fix what's in front of me right now because it's there, which, hard to fault that, or I'm going to fix this because it's the most recent thing that popped up in a scan. And so like it's fresh and I'm just going to go after that one. But in order to really get after this from a security perspective, you've got to kind of level it up a little bit and be thinking about how does the overall bucket of flaws that I know about affect the risk posture and go at it in a more prioritized fashion. The other thing you can do other than increasing capacity is just getting better at fixing the flaws themselves, right? If I can, for example, learn how to fix a SQL injection problem in 5 minutes instead of 30 minutes, I'm just making those numbers up. It takes a little longer probably, but then I've effectively increased my capacity. because now I can tackle 6 times more in the same amount of time. And so getting better, whether that's through education, whether that's through sort of generative AI assisted type fixing, any ways that we can make ourselves better at the task at hand, effectively increases our capacity and allows us to chip away at more of the debt. So those are some things that teams can do.
Absolutely. It's like any debt, whether it's credit card debt, technical debt, or security debt, kicking the can down the road is just never a great solution. And, it's easy for me to say, and, but when people find themselves in this state, it's kind of usually too late for that, but you got to start somewhere. And there's no better day than today. Chris, beyond technical debt, beyond security debt, what other kind of big, highlights from the report this year?
That is the bulk of it, because it's such a big problem, and we slice the data a lot of different ways, and kind of look at what's happening and the factors that affect that. We do have another section, a section at the end of the report that kind of follows on some open source research that we did last time. We started looking at what was on GitHub and some of the characteristics that we thought might, lead to more risk. For example, this was last time, so we looked at repositories and how often they were updated, or how many developers were on them, those types of things. And we pushed a little bit more into that direction this year, asking questions like, how much risk do you get out of using open source when there's only a single developer? Or like, if you look at the percentage of applications in a particular language that are using code from a single developer, right? There's a lot of libraries out there that are very popular that have one maintainer. And so what does that risk look like when you think about that in terms of the organization? If they introduce a bug, if their account is taken over, if they decide to disband the project, like those types of things. And then we looked at OpenSSF, which I'm sure you probably come across it at some point, but just sort of industry work to kind of do many things, but they have this notion of a score that they put on open source libraries that looks at a number of different factors to gauge sort of how secure that library is. And it's more about practices than vulnerability counting, right? Are they using, are there signs of dangerous coding patterns? Do they use branch protection? Do they use code reviews? Do they use SAS scans? All these things that kind of almost like a maturity model type thing, right? And so we looked at the scores of open source libraries that they've assigned scores to, and then we've looked at open source libraries that we see actually in use in real world applications from our customer base. And we actually saw that the libraries that we saw in use tended to have on the higher side of OpenSSF scores. Now, I'm not saying that people are using the OpenSSF score to decide what they want to use, but there does seem to be a correlation there that people are leaning towards the libraries that have better practices. And so that's sort of a good sign. There's a lot of data there, right? But we wanted to kind of see what that was looking like. So there's a whole section there on open source, what that looks like in the ecosystem, how the influence that individual developers have, and stuff like that. So worth a read. But our focus was really, let's get into this security debt discussion that nobody wants to have, and let's have it. And honestly, I saw Ollie Whitehouse over at the UK. I'm forgetting the acronym now, right? But it's their CISA basically. And he was saying, like, one of the top priorities for the year, as he's concerned, is like getting the security debt conversation happening and figure out ways to get after that, because it's just this looming problem that comes back to bite us every time something big happens in the industry. So it's a conversation that needs to happen.
Yep. And I think it's a topic that we are going to see throughout the year. I hope to see some of it maybe at RSA, where I usually see you.
I usually see you. Yeah.
Yeah. Hopefully we'll see you there. Again, for folks who want to download the report, you could go to veracode.com/SOSS and get it right from there, or just at veracode.com. I'm sure there'll be links off the front page.
You'll find it.
Yep. Hey, Chris, as always, thanks for coming on and talking it up and informing us, enlightening us. Best of luck, and come back. Well, if I don't talk to you before, I'll see you in May, but maybe before.
That sounds great. Thanks for the chat. Always a good conversation.
All right. Chris Eng, Chief Research Officer at Veracode here on TechStrong TV. Tell you one thing. You know, Mitchell, I have less hair than I did 20 years ago. Yours is much more gray. But even Chris Eng has gone gray on us.
Yes. We just hang around too much together for too long.
Yeah, it makes you realize, Mitch, here's to us and those like us. Damn few left.
Yeah. But we're hanging on.
But Chris is definitely one of them. And look, he does a great job there at Veracode, as does Chris Weisfeld. I mean, it's still a great company.
And a lot of people follow that. I mean, that report's important.
I mean, look, they've been setting the mark in the AppSec, I think, as long as there's been an AppSec.
Mm-hmm. Yeah, for sure.
So, and I'm lucky. I mean, whenever they have some kind of news like that, Chris, I guess, tells the PR people or whatever to reach out to me. Mm-hmm. And him and I get together to discuss it. So I probably interview Chris 3 or 4 times a year, and I usually see him at RSA or Black Hat. Yep. And as a matter of fact, we made plans. We'll see him at RSA again this year.
Mm-hmm. Mm-hmm.
Good stuff.
He's talking about real things, real data, right? And the analysis from it. So it's not just pontificating about what we think's happening.
No. I mean, the thing about Chris Eng is this is a real deal security guy who's now been doing the research at Veracode for a very long time. And so it's not your average analyst, right, who is riding that gravy train. And no disrespect, Mitchell.
Hey, none taken.
All right. But
yes.
he's a real security guy. So really, really happy with that.
Well, this
anyway,
is great. I appreciate you bringing that interview forward so folks could listen and watch.
Yeah, no, and if you want to see it again, it's available on TechStrong TV, as is Mitchell. These podcasts, if you're listening to it on Apple or watching it or on Spotify or wherever, you can catch it there. You can also catch it on our TechStrong TV YouTube channel, as well as on TechStrong.tv as well. So there's no lack of outlets to watch your favorite podcasts here on TechStrong.
Every part of our global takeover plan.
Omniversal. Anyway, Mitchell, thanks for having me on Security Boulevard Chats and joining me this week. We'll be back next week with more.
Yep, and you've been listening to
Security Boulevard Chats.
Join us next time.